Coterminal angles. Let's remember what coterminal angles are. So coterminal angles, these have the same terminal side in standard position. Okay. So coterminal angles correspond to the same points on the unit circle, so they also must have the same trigonometric values. So let's take a look at that if we draw out a unit circle. And we'll just use an example, but it can apply to any coterminal angle set. So let's say I want to look at, of course, this is our initial side. Let's say this is our terminal side pointing straight down on the negative y-axis. We could call this 270 degrees, but I could also call this negative 90 degrees. And this point corresponds to 0, negative 1, okay? And so from here, what this is saying is that coterminal angles, okay, they correspond to the same points. Well, they also must have the same trig values. So that's telling me, like, I know that on the unit circle, we know more than this, but let's just say x is cosine t, y is sine of t. So we know about the other 4 trig functions too, but just for this example, we'll keep it to this. So what this is telling me is that cosine of 270 degrees is the same thing as cosine of negative 90 degrees, and that both of those would be equal to 0 because they're the x-coordinate. Sine of 270 degrees is the same as the sine of negative 90 degrees, and that in this case is negative 1. So let's remember, how are we able to tell if two angles are coterminal? So not just looking at them, right? We can tell pretty easily just by kind of staring at them, but what if we just saw two angles, and how would we know if they were coterminal? So coterminal angles, what do they look like? So we would say theta is coterminal with any angle. So theta plus theta times 360 degrees. We want 360 degrees, not another theta, 360 times k, where k is an integer. We can also do it in radians. So we'd have theta plus 2 pi times k, where k is an integer. So it just means that if you're a full rotation or some number of full rotations in either direction away from that given original angle, then that creates a coterminal angle with the original angle. So let's evaluate the following expressions, kind of putting everything together. So let's look at cosine of 7 pi. So how could I do that? Well, I could find a coterminal angle that's on the unit circle, but sometimes it's just easier to draw it out. I know a lot of people are visual learners. You like to just kind of see it. And a lot of times it's possible to do that. So if I wanted to say, well, where is 7 pi on the unit circle? Well, I know 2 pi is 1 time around. 4 pi would be 2 times. 6 pi would be 3 times. All right, run out of room, but we're almost there. So to get 7 pi, I just need to go to this other side here. And so 7 pi is going to correspond to this point here, which I know is negative 1 comma 0. So because of that, cosine is 7 pi. I can see that this is the same as cosine of pi, all right? But I don't even need that. So I can write that just to kind of remind myself. I'll write my pi a little better in here. So I can write that to remind myself. I don't really need it. So cosine of 7 pi is equivalent to cosine of pi. This case is negative 1. But just drawing it out, I can see that, but I don't, again, need to write the cosine of pi. All right, let's try another one. Tan of negative 45 degrees. So all I'm really doing is saying, where is negative 45 degrees? Okay, well, it's just down 45 degrees, so it's here. And then I want to identify, I'm like, wait a minute, on the unit circle, what point is that? And I go, okay, that's root 2 over 2, negative root 2 over 2. And so I don't even need to find the coterminal angle that lives on the unit circle, right? When we label the unit circle, we label it for one full positive rotation. So 0 to 360 or 0 to 2 pi. But I don't even need to go, wait a minute, what angle is that on the unit circle that I have labeled in that, when we fill out the chart? In this case, I can just go, I know what place it's in, and that's good enough. And so the tangent is going to be y over x, so negative root 2 over 2 over root 2 over 2. So this is just something divided by itself, but they're opposites, so the answer is negative 1. Okay, so let's do that same kind of thing. So what's sine of negative 3 pi over 4? So all I do is just draw out my unit circle, and I'm going to go find where that lives. So really, I'm finding its terminal side. So negative 3 pi over 4. Well, think about your chunks, right? Pi over 4 would be that size. So this would be down pi over 4, down 2 pi over 4, down 3 pi over 4. And then I would need to be going in that direction. So I want to end up right here at this point, which is negative root 2 over 2, comma negative root 2 over 2. So as long as I'm at that point, I don't care that, okay, on the unit circle, this is 5 pi over 4, and that's what's labeled there, right? That's fine, but I can just get there directly by finding the place on the unit circle because I know that two angles that share that terminal side, they're coterminal, so those sine and cosine values will be the same. All right, so this is the sine value, it's the y, so it's a negative root 2 over 2. All right, now this is kind of putting it together so it says, hey, are you remembering other things we did? So secant, we know, I can think about it in terms of x and y on the unit circle, but oftentimes you'll see people just put it in terms of sine and cosine if they can. And I got some wonky pies today. Here we go. So this is 1 over cosine pi minus 1 over sine of pi over 2. And then I just go from there. So I go, well, what's cosine of pi? So I go, all right, unit circle time, draw my unit circle. Where's pi? It lives over here. So I need this point, which is negative 1 comma 0. So this is 1 over the x value. So 1 over negative 1 minus 1 over, so what's sine of pi over 2? I can just use the same circle. Pi over 2 is here, so I care about this point, 0, 1. So this is just 1 over the y value 1. So now just gives me a little bit to simplify. So I say, well, this is negative 1 minus 1, which is negative 2.